Hello, I am Alexa Su.
Hello, my name is Gene Kim, and today we will be sharing our work on supporting accessible data visualizations through audio data narratives.
In this work, we investigate audio data narratives, an accessible data representation for screen reader users that makes use of image descriptions and sonification to provide direct, multimodal, and up-to-date access to data.
Online data visualizations play an increasingly important role in informing the public and guiding decision-making. However, much of the guidelines and tools used for creating visualizations have primarily focused on visual means of access. Fewer alternative representations have been explored to support screen reader users who rely primarily on non-visual ways of accessing data. Prior research has reported several challenges and limitations to existing accessible representations, including image descriptions, sonification, and tabular data.
Image descriptions are among the most common and recommended by guidelines. However, they do not provide direct access to the data and instead only capture the author's interpretation of the data. Audiographs through sonification are less common but provide more direct access. However, interpreting auditory graphs is not always easy with a few standards in place and not much training or guidance available for users. Interpretation also becomes considerably more difficult with complex real-world datasets. To address several of these limitations, we propose using audio data narratives to bring together the benefits of description and sonification, using descriptions or narratives to guide the user while maintaining users' direct access to the data through sonification, supporting users in gaining their own insights from the data.
We conducted 2 co-design workshops to understand how audio data narratives might make audiographics easier to navigate and interpret. 4 blind and visually impaired co-designers, primarily screen reader users, participated in recurrent remote sessions. Our exploration centered on generating ideas on effective narrative design patterns and resulted in a set of design guidelines.
I'll highlight 2 main points of commonality across some of the prototypes that came out of the design workshops. First, in structuring information in an auditory narrative. For complex datasets, users prefer segmenting as sonification and listening by prominent or salient features that made it easier to identify, reinvestigate, and remember its parts when listening to sequentially. Second, foreshadowing. Users wanted coordinated access between the description and sonification, with the speech helping guide their attention by providing commentary on upcoming prominent features in the sonification. This context was important to create a better expectation of the audio and interpret the sounds. Here is an example of one way in which a co-designer explained using the sonification and description to better emphasize a small change in the audio. I'll play a small clip of that.
Adoption of landline telephones started at a low 10% in 1920 and quickly increased. Then the Depression came and it dropped quickly but came back up.
With an understanding of how to effectively guide the design of a data narrative, we apply these insights to develop an automatic approach to generate audio data narratives. We use a heuristics-based approach along with dynamic programming, driven by the design guidelines we defined with our co-designers, as well as auditory perception thresholds and prior work on sonification parameters. Applying this process, here is a data set of COVID positivity rate in Peru, and each segment is highlighted in a different color. I will now play just the first segment of what the audio data narrative sounds like for this data set.
COVID positivity rate in Peru. In February 2020, COVID rate was 0.0% and then it increased sharply to all-time high of 37.7% in April 2020. It sounded like this.
To assess the effectiveness of this approach, we conducted an overall evaluation of audio data narratives created using our guidelines and heuristics method. 16 screen reader users participated in the study. Participants accessed an audio representation of a data set in one of 2 different ways. First, the narrative condition, wherein descriptions and sonifications were interleaved in different segments. In the control condition, there were no segments. The full description was followed by the entire sonification. Both conditions had the same duration and content, The only difference was how the information was presented. As a second factor, we experimented with varying levels of complexity in the datasets.
Participants provided a description and takeaways from the representation that they listened to. To understand what participants learned, we coded participants' insights based on different data facts. Additionally, we categorized an insight as exact or inferred. An exact insight was information that was repeated from the description, and an inferred insight was information that was not explicitly spoken. Plotting the proportion of inferred insights for each condition and complexity level, we find that the narrative condition had a significantly higher proportion of inferred insights compared to the control without segments. The line is higher up. In addition, we find that there is an interaction with dataset complexity. In the control condition, users provide more insights when the dataset is simple, but not so many when it's complex, 29% versus 13%, indicating that participants could make more inferences from the sonification when the dataset was simple. On the other hand, in the narrative condition, we see that there is no significant difference in insights between the complex and simple datasets. Both are high at 30 and 36%. Taken together, this provides evidence that the narrative helps users better interpret and make use of the sonification to gain insights, especially for complex datasets.
With the narrative condition, participants described their understanding of the data to be more detailed and requiring less effort. Participants felt that the descriptions were well complemented by the sonification details. While for the control condition, without segments, participants described their understanding as more general. In summary, we investigated the use of description and sonification to improve the understanding of audio graphs. The evaluation results show that audio narratives support independent access and interpretation of data insights. Participants were enthusiastic about being able to understand the data at a greater depth, especially when compared to more traditional access representations.
In future work, we would like to explore additional interactions. Participants often had additional queries or segments that they wanted to investigate in more detail. Here, we focus on evaluating the method, but believe there are many opportunities for making the narratives more interactive and also adjustable to users' different tasks. There are also opportunities for the narratives to be more engaging, to provide additional external context as well as annotations. And last, here we focus on time series datasets and would like to investigate how this can extend to other common types of data shards.
Thanks so much for listening, and be sure to check out our paper for more details on this work.